Hello, my name's Jack. I'm a sound designer with a decade of experience as a vehicle technician. Today I'm going to be walking you through how I implemented vehicle audio using Unreal Engine 5 and Wwise. So first of all, for the vehicle engine system, the goal was to create a responsive engine setup that can react to the car in real time whilst also changing perspective depending on the camera view. I use Crankcase Audio REV inside Wwise as the core of the engine system. REV uses a granular playback engine, so instead of looping multiple engine RPM sounds, it can move through recorded engine material based on real-time game parameters. For REV to work, it needs a few RTPCs connecting to the existing vehicle logic. These are gear shift on or off, current gear, RPM, throttle, which is load on or load off, and velocity, which is vehicle speed. For the purposes of this video, I won't get too far into the deeper logic behind how all the blueprints work, so I'll just give an overview for now. For gear shifting, I use two separate input actions for gear up and for gear down. These both call the same change gear function, and that function adds or subtracts from the current gear. It then checks that the result is within the valid gear range, and then sends a new gear value to the chaos vehicle movement component using set target gear. I then store the gear shift up and down as a Boolean variable. I then take this variable and convert the false to a 0 and the true to a 1. This then feeds the Wwise RTPC as a simple on or off control signal and lets REV know when a gear change is taking place. For the current gear feed into REV, I'm simply using a get current gear node and converting that from an integer to a float to output as an RTPC. I've then added a print string with an append node for debugging. From the vehicle movement component, I use the get engine rotational speed to read the car's current RPM value on tick. Because REV expects a normalized RPM control value, I then use a map range clamped to convert the vehicle RPM range into a 0 to 1. In this case, the input range is 950 at idle and 7100 at max RPM. In the case of throttle, I'm using an input axis node, which gives me a float value from the player's accelerator input. So when the player is off the throttle, that value is 0, and when they press the accelerator fully, it moves towards 1. That same input value is used to drive the vehicle movement, but I also clamp it between 0 and 1 and send it to Wwise as the throttle RTPC. And then inside REV, this RTPC value then crossfades between acceleration and deceleration ramps. For the speed RTPC, I'm essentially using get forward speed, and then I convert that from meters per second to miles per hour inside my speedometer. I then take the miles per hour data and splice into that to set the speed RTPC. For this project, I actually used real Nissan GTR recordings and edited out idle loops, ramp ups and ramp downs for each of the camera perspectives used in game. For REV to analyze and track properly, these files needed to have clear, consistent and defined harmonics. Using RX, I've removed just enough noise around the harmonics, attenuated some of the wind from the recordings, and filled in breaks in harmonic content with signal generators. After the files were cleaned, it was time to import them into REV, set the start and end boundaries, tag the harmonics, and save each ramp as a partial file ready to load into each camera perspective model. On begin play, the default chase state is activated and a Wise event is posted which starts the playback of all 3 engine perspectives simultaneously. These consist of the exhaust recordings used for chase view, the engine bay recordings for the hood view, and the interior recordings for the cockpit view. As the player cycles through the camera views using the controller input, the corresponding Wise state is selected. All 3 perspectives continue playing in the background, whilst the state system controls the volume levels. So that covers the core engine implementation, including source preparation, REV modeling, blueprint logic, and state-driven camera mixing. Please check out other videos where I'll go through further systems in more detail. Thanks for watching, and feel free to reach out using the links in the description below.